Welcome to my presentation. In this presentation, we shall try to find the algebraic representation of a vector. In here, if 2 points are given to us, one is the initial point, another is the terminal point, and if we want to find the algebraic representation of that, how do we do that? So this example is going to explain that. If the first point is 4 comma negative 3, and if the second point is negative 2 comma 4, if we call 4 comma negative 3 as the initial point and negative 2 comma 4 as the terminal point, then we can represent this algebraically as follows. Solution. The algebraic representation is going to be vector v is equal to ai plus bj, isn't it? That's what we have seen. In here, a is, let me, before I plug in the numbers, I want to represent this particular, these initial point and terminal point in graphical manner, and the way to do that is as follows. So this is the origin. This is point 1, 2, 3, 4, and this is negative 1, negative 2, negative 3, and so on. So in here we have 1, 2, 3, 4, and then 1, 2, 3, and so on. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, positive 1, 2, 3, 4, and then negative 1, negative 2, negative 3. So in here, the initial point is 4 comma negative 3, 4 comma negative 3. So we're going to go 4 units on the positive x-axis, 1, 2, 3, 4 units, and then 3 units down, 1, 2, 3 units down. So this point here is 4 comma negative 3. And then the second point we have is negative 2. We're going to travel 2 units on the negative x-axis and then 4 units on the positive y-axis. 1, 2, 3, and 4. This is the point we are looking at. So this is negative 2 comma 4. So we're going to join these 2 points with a straight line, and with a straight line, when we do that, this is how it's going to look like. So we have an initial point and we have a final point. If we call this point as x1 comma y1, and if we call this point as x2 comma y2, then we can now represent algebraically this particular vector. So the way to do that is as follows. In here, a is going to be equal to, in here, a is equal to x2 minus x1. x2 here is negative 2, and x1 here is 4. Therefore, when we simplify this, this is going to simplify to negative 6. Negative 2 plus negative 4 is negative 6. Similarly, b is the magnitude, and then here again, b will be equal to y2 minus y1. y2 minus y1. And therefore, y2 here is 4 minus y1 here is negative 3. Therefore, 4 plus 3, that's going to be equal to 7. In terms of representation, I'm going to represent that by another color. If I were to draw a line here and then draw a horizontal line here, this distance here is the b distance, that is equal to 7. This distance here is the a distance, and that we have seen as equal to negative 6. So we got the values of a and the value of b, and therefore now we can come back and then represent the algebraic vector as follows. The algebraic representation of a vector is ai plus bj. A here is equal to negative 6i plus b is 7j. So the vector v, we can represent that as negative 6i plus 7j. This is the algebraic representation of that vector. In my next presentation, we shall see some more examples related to vector operations in 2 dimensions.